Hello and welcome to another exciting project called as Drone Surveillance for Search and Rescue. So what we are going to do in this project? So let us understand this by taking a scenario. Let's say there is a person who is lost in a remote area. Now, and we have launched the search operation for that person, search and rescue operation for that person. So what we are going to do is we are going to have a drone, and that drone will do the surveillance of that particular area. Of course, the drone is equipped with the camera, right? So drone will do the surveillance of that area, and drone will capture the video of that area, and that video feed will be given to our system, and our system will detect, go through that video, process that video, and detect if there is a person in that video. That means if there is a person in that area. So if it is there, it will locate, and thus will help us in the rescue operation for that person. So that's what we are going to do. Now, how are we going to do that? In our project, see, we are not going to use a drone, right? We are going to use a video clip in which we will have some person, and we will check whether that video clip will give as input to our project, and will our system, and we'll see whether our system is able to detect or locate the person in that video or not, right? Okay, so let me show the video to you first. So this is the video which I'm going to use, right? So our system must be able to locate this person, these person which you're able to see, right? So that's what. So our system will just put the boxes around this person, right? So bounding boxes or rectangles locating these person. So now let's go to the code part of it. Now, what we are going to use? We are going to use YOLO model. YOLO stands for you only look once, right? So it's a deep learning model. It's a deep neural network. So we are going to use that YOLO version 3. So we will download the architecture or the configuration of YOLO version 3 from this, right? From this URL, we are going to download it. So this configuration file means the architecture of the neural network. Architecture means the neural network containing all the layers, right? So that we are going to have in this YOLO version 3 configuration file. And then we are going to use pre-trained YOLO. That means the YOLO. What do you mean by training of a neural network? Training of a neural network means teaching a neural network something, or the neural networks learn something, right? So when the neural network learns something, the weights of the neural networks gets updated. So we are going to use the neural network or YOLO model, which is trained on the COCO dataset, right? So COCO is a dataset containing thousands of images, and those thousands of images are given as input to our YOLO model. And that means that YOLO is trained on COCO dataset. COCO dataset contains various images having 80 distinct objects. That means there are 80 distinct objects. That means when we train our YOLO on COCO, our YOLO model will be able to detect up to 80 different objects, including a car, a person, some animals, and all that, right? So there are 80 distinct objects in the COCO dataset, right? So I will download this weights file. That means this weights file is the file containing the weights which we got by training our YOLO on this COCO dataset, right? So that means these are ready-made weights. We need not train, right? So these are trained weights, right? So these by using these weights, when I put these weights on our YOLO configuration file, it is as good as this YOLO has learned. It is trained to detect those 80 objects. That means if the image which is given as input to this YOLO, if it contains one of those 80 objects, so this YOLO will be able to detect that, right? Will be able to identify that, locate that, right? So that's why we are going to download these three files: YOLO.weights. These are pre-trained weights on which YOLO is trained using COCO dataset. Then the configuration file, that means actual YOLO model. This is the actual YOLO model containing the information about the layers and what how many layers are there, what are the names of those layers and all that, right? Then this coco.names, this is a text file containing the names of the objects. There are 80 objects, so this file contains names of those 80 objects. So that file will need, right? So let me run this and get those files with me, right? You see these files are not there. Yeah, these files you can see YOLO version 3 uh, configuration files and YOLO version 3 weights, right? So these three files, and coco.names is also there, right? So we have these three files are downloaded. These three files, coco. In fact, I am running this program second time. That's why you are able to see these coco.names twice, right? So in fact, every YOLO version 3 dot weights, YOLO version 3 dot weights 1 configuration 1, because I had already run this program. Now again I have downloaded those files. That's why this repetition of names. So the bottom line is all these three files are downloaded in my Google Colab. Right? Now I will download the required libraries. What are the different libraries? I will use OpenCV. So import CV2. Then I'll use NumPy because ultimately we are going to perform image processing tasks here, and images are represented by using n-dimensional arrays or multi-dimensional arrays, and that support is provided by NumPy. Then this is CV2 underscore imshow is a function to display an image in the this Google Colab. So CV2 underscore imshow. If you're using Jupyter, it will be CV2.imshow, right? So we'll be importing that as well. Then we'll be importing files in order to upload the file in Google Colab, download the files from Google Colab. So let me run this. Yeah. And now we'll load our YOLO model, right? So what is our YOLO model? A pre-trained YOLO model, weights and the configuration file, right? So I'm loading that by using readnet function of DNN module, right? In OpenCV, there is a DNN module. In that module, there is readnet function. By using that readnet function, I'll be loading my YOLO model. YOLO model is nothing but pre-trained YOLO model is nothing but weights and the configuration file. Right now, so this YOLO model I'm storing in a variable called as net. So net is the name of our YOLO model or YOLO neural network in this program. So this net is the name of our YOLO deep neural network or YOLO model. Now, what are the different layers and what are the names of those layers? I'll be extracting those, right? So on this net, I'll be calling a function called as get layer names. So this function will give me the names of the different layers in this YOLO model or net. So this names like convolutional layer, pooling layer, and some other types of layers, right? So those layer names I'll get, and those layer names I'll be storing in this layers underscore name variable, right? So I'm creating a list. I'm creating a list of the layer names, and that list name is layer underscore names. Okay. Now I'm interested in output layers only. Why? Because those are the layers which will process the input. Those are the layers which will process the input and produce the output, right? So output, I'm interested in finding the output layers, right? So this function I'll call net dot get you connected output layers, right? So this function I'll call, this function will return me the output layer indices. That means if the number indices mean the number of the output layer. So let's say layer number 3, 6 and 9 are output layers. So this will give me a list containing 3, 6 and 9, right? This will give me a list containing 3, 6 and 9. Now I don't want indices or number of the output layers. I want the name of the output layers, and from where I'll get those names? From layer underscore names, right? So layer underscore names hold the name of all the layers, right? And from out of all these layers, I want just layers with these indices written by this, right? So in this will return a list, right? This will return a list. So I'm iterating through that list. So this for I equal to, I will take, let's say, let me show you, this is the list 1 3 comma 6 comma 9. Let's say this is the list written by this function, right? Just replace this with I'm sorry, something, yeah, just replace this with this list, right? That means I am iterating through this list by using this I. So I will take this value 3, right? I will take this value 3, and with this we are going to layers underscore layer names list, and finding what is the name of the layer with this index. What is the name of the layer in this? That means I'm going in this, right? So why this I minus 1? Because layers are numbered from 1. Layers are numbered from 1. In any neural network, layers are numbered from 1, but list contain the indices start from 0. That's why this I minus 1, right? So, when this I is 3, this will be layer underscore names of 2, right? So that layer name I'll get from the layer underscore names. So in fact, what we are doing, we are just extracting the output layer names by using this code. So this is returning us the output layer indices or output layer numbers like this. And by using these numbers, we are going to output a layer underscore names and extracting the name of that output layer, or in fact all output layers. Okay, so this code is giving us the output layer name. So let me run this code. Now I'll be, as I said, there are 80 different object classes in the Coco dataset, right? And those object names are available in the file called as coco.names. So we are going to extract those names. We are going to open that file in the read mode, right? And from that file, we are going to extract the names of those objects. That means 80 names we are going to extract and put those in this classes, right? Classes list, right? So this code is for line. This code will again iterate through each line of this file coco.names. So coco.names is open in the read mode as f. F is just the name of the variable, right? We are calling this coco.name as f, right? And this is open in read mode. So f.read lines means in this file we are reading this file line by line, one line at a time. When we read that line, see the object names are stored one per line. So we are going to read that line, right? And there will be some trailing or leading white spaces. So we are going to strip those, right? Stripping those and just picking the object name and putting in the classes, right? Classes list, right? So this will get the classes. So okay, so then I'll upload my, in fact this should be the camera feed, right? This is where this is where you should provide the drone camera feed, but now we are using the small video clip which is as good as taken from the drone camera. This is actually taken from drone camera, and I am using that clip which already I have, right? So that clip in the real life scenario, you will be having the drone which will be doing surveillance, and that drone will have camera which will capture the video, and that video will be provided to your system by means of Wi-Fi or some other media, right? So so here we are using a video clip, right? So I'm uploading that from my local hard disk. So I'll choose a file. So this file, right? So this file drone 1, this file I'll be uploading. You see the file is getting uploaded. So 1% done, 3%. So let me pause the video just to cut short the time. You see the file is 100% uploaded, right? So the video file is stored as drone1.mp4, right? So drone1.mp4. So I guess it's let me just check. Yeah, this file, right? So this I have two files here because one I already uploaded. As I told, I have already executed this program. So this is the file is just now uploaded here, right? So but I'll be using anyway. I can use any one of these because both are same files. So the file is stored as drone1.mp4. So I'll be using that file. I'll be loading that file into this variable called as cap. This cap is the name of the video file in our program. This is the name of the variable. This is the name of the video for our program. In our program, we are calling that video as cap. So by using cv2.video capture, we are loading this video file into cap. Video file is loaded. Now we'll check whether the video file is correctly loaded or not. right. Yes, the video file is correctly loaded, so it's open. So that's why there is no error, right. Then what we'll do, we'll initialize the width and height for this frame, right. So we are going to read this video file. So cap dot read. So this will read one frame. This will read one frame of the video file. What is the name of our video file? Cap is the name of our video file. So we are going to read that. So that frame will be stored in this variable called as frame. Frame means nothing but one photo, right. So this video is formed from images. Video is nothing but sequence of images played one after the other, right. So there are video contains images which are sequentially played, right. So they are played so fast that we are not able to notice the difference, right. And then we are these images are called as frames. So we are picking one frame and storing it in this variable called as frame. And if the frame is correctly read, this ret is a boolean variable. This will be set to true if the frame is correctly read. If the frame is not correctly read, this ret will be set to false, right. Then we are calling this shape. We are getting the shape of the frame, right. Frame dot shape. This will give us the width of the frame, the height of the frame, and the number of channels, color channels, right. So height, width, and channels. This shape will return these three things. Channel means color channels. That is RGB, red, green, and blue. Okay. Then we are setting from where to read the video, right. So this video can be this cap underscore prop underscore pause frames. This will set the position or the index position. This will position us in the video. That means what is the next number of the frame from which we should start reading the video or start playing the video, right. So cv2 dot this will point to the frame from where we want to read that video, play that video. So we want to start from beginning, so that's why 0, right. So cap dot set 0, that means we are starting the video from the beginning, right. And then we are taking a variable called as frames, right, and this frames will contain the processed frame, right. So what we are doing now, we will read that video, we'll go through that video one frame at a time, right. We will pick a frame from the video and then we'll pass that frame through this code, and this code will process that frame. What processing we are doing? We are detecting the object in the frame, right. Person, object, nothing but person. We are detecting a person in the frame. If we find a person, we will put a rectangle or bounding box around that person, right, and will be storing that process frame in this frames variable, right. Okay, so let's open the video. Let's open the video. So while cap dot is open, that means while the video is open, while the video is playing, right. So what we are going to do, we are going to read that video one frame at a time. So we'll read a frame in this frame variable. So cap dot read will read a frame. That frame will be stored in this variable frame, and this ret will be true if the frame is correctly read. If the frame is not correctly read, then this ret will be false. So if not read, break. That means if this ret is false, we'll break from this while loop. We'll come out of the while loop. Else what will we do? We'll do the processing of that frame, detecting the person in that frame, right. So what we are doing, we are again finding the height, width, and channels in that frame by using frame dot shape. So we have height, width, and channels, color channels, RGB, right. Then we'll detect an object in that frame, right. So we'll detect an object in that frame. So now see, here we'll be using our YOLO model, right. So we'll be passing that frame to the YOLO model, but our YOLO model expects a frame as input in the form of something called as blob. It's a 4-dimensional tensor actually. So we'll be converting our image into this blob, right, by using this blob from image function from the DNN model. DNN stands for Deep Neural Network Model of OpenCV, right. So we are calling a blob from image function, so that to that function we are passing our frame. This is the scaling factor of the pixels. That means how the pixel should be scaled. And this is the requirement for for giving the input to the neural network. So each pixel will be scaled with this factor. That means we are multiplying this with the pixel values. Then this is the size of the output image, as this YOLO is trained on this size of the images. So this is the size of the output image. This is called as mean scaling. Actually, by using this, what we are doing, we are subtracting. This is called as mean subtraction. We are subtracting this value from each pixel, this value, right? So pixel is in the form of RGB. Pixel has three components: red, green, and blue. So red component, from red components will be subtracting this 0. From blue will green will subtracting this 0. From blue will subtracting this 0. Now here we are doing mean subtraction, but actually we are not doing anything. This is for the purpose of normalization. But if there are some values, like here, this instead of 0 we have 100, right? That means from green component of a pixels in that image, a red component of pixel in that image will be subtracting 100. Again, from, if I have some value, I'll subtract that value from the green component, right? So on and so forth. So this is called as mean subtraction, just for normalizing the pixels. Then this true means now OpenCV loads the image in the form of BGR, right? BGR. OpenCV loads in the image in the form of BGR, but we want to convert that image in the form of RGB, because that's the requirement by the neural network. So we'll convert this. True means convert the image which is in the form of BGR into form of RGB, right? Crop equal to false means no further cropping of the image, right? So this function is converting the frame, which is our image, right, which we got from the video. That image is converted into blob, and that blob is called as, this is just a variable name. This is just a variable name which contains the input, which is ready to be given as input to the neural network, that is YOLO. So now we are setting this input, right? So set input blob. On this neural network, we are calling a function set input blob, and to that function we are passing blob. That means we are passing this blob as input to our neural network, right? Then we are passing this input through the in the forward. This is actually a forward phase. In the forward phase, we are passing this input through the output layers, and those output layers will produce the output, and that output will be stored in this list called as outs. So outs will contain the output produced by. So this is actually where detection is happening, right? So this is where the network is processing our frame, processing our input image, right? And this input image is going through the output layers, and those output layers will produce the output. That means the detected objects, and those outputs we are going to store in the outs variable. Now question is, how many outputs will be there? The number of outputs will be equal to the number of output layers. In case of this YOLO version 3, there are 3 output layers. So this outs will contain 3 outputs. This outs will contain 3 outputs, one from each layer, right? So why 3 output layers? Because YOLO version 3 has different output layers for different scaled object. That means large objects will be detected by output layer 1. Medium size objects will be detected by output layer 2, and small objects will be detected by output layer 3, right? So for example, I'll show you here. Yeah. So yes, so you see, this is how your outs may look like. So this is the output produced by layer 1. This is the output produced by layer 2, and this is the output produced by layer 3. So this outs is containing 3 elements, one element coming from one layer. Right now, that layer 1, what layer 1 is doing? Layer 1 is detecting the large objects, right? So there might be n number of objects. No, so this is object 1, that is called as detection 1. This is object 2, that is called as detection 2, so on and so forth. So similarly, layer 2 will also detect many objects, because there might be many medium size objects in the image, no? So layer 2 will detect object 1, layer 2 will detect another object, so on and so forth. This is detection 1 by layer 2, detection 2 by layer 2, right? So see, remember, this and these are not same, right? If this is a car, right? This might be a person, right? The car was small, that's why it was, so the car was large, that's why detected by this this output layer. The person was a small object, that's medium object, that's why detected by second layer, right? So I hope you understood, right? And now, how does this each individual detection look like? Each individual detection look like? This each individual detection is a vector, right? So this is the vector, right? So this first, this is the center coordinates, center coordinates of the bounding boxes, right? So in fact, this output which you are getting, output of the neural network, is the bounding boxes which will be put around that image, right? So this is the center coordinates of the bounding boxes. These are the x and width and height actually. This is width, normalized width and height, right? This is next parameter is called as confidence score. That means how confident the model is that the detected object is an object indeed. It's not a part of the background, it's not a noise. So that is called as confidence score. That means 0.9 means 90% this model is sure that it's detected is an object, in actually object. Then these are called as class probabilities. There are 80 such probabilities. Why? 0.1 means if the class 1 is person, let's say the 0.1 means the probability of this object belonging to class person is 10% or 0.1, right? So then probability of this object belonging to second class is 0.05 or 5%, so on and so forth. So there will be 80 such probabilities, right? Okay, so that's what this detection output. This is how output of outputs of the output layer looks like. Okay, let's get back to the code. I hope you understood, right? Now, once we got these outs, that means now we have the out detected objects in the outs layer, right? So what we said, in outs we have three elements in this particular case. Let's say we have three elements, right? So each element is the output of one output layer, right? So now we are going to go through each of those layers output, right? We'll pick the first output layer, right, from the outs, right? So and then in that output layer, again in that layer's output, we have various detections, right? So we are going to go through those detections, right? We are going to go through those detections. For example, if you see, I am going to pick this first, right? So when outs, now what we are saying, out in outs, right? So for out in outs, so this out will take this value, this will be out, right? So now when out is this, I am going to iterate through that out, because this out itself is a list. So I'll be going through each element of that list. That means again I need one more loop, right? So this is the loop which is helping me to iterate, right? Okay, so before that I am taking three arrays. First array is called as class IDs to store the IDs of the detected objects. Then confidence score, that means this will store the probability of the the class to which that object can belong to, right? So then this will be store the coordinates of the bounding boxes, right? So now let's go through one detection at a time. So what we did here, we pick the first output layer, output of the first output layer, and in that we are going through one detection at a time. So this detection is storing one detection, right? So for example, this detection will store this detection 1, layer 1, right? So we are looking at this now. We are looking at this in the first iteration. This detection is storing this, right? And in this detection, what is there? So this is the vector. This is the vector, right? So in this vector, we are now in this vector, right here. When we are here, we are inside this vector. Inside this vector. And what is there inside this vector? This is location 0, 1, 2, 3, 4 and 5. This is fifth location, and fifth location onwards we have the class probabilities, right? That means the probability of an object belonging to particular class, right? So we are finding those probabilities. We are picking up those probabilities and calling those as scores, right? So from 5 location 5th onwards in the detection location 5 onwards. So this will give us a slice, right? So that means we'll get only the class probabilities, right? And those we are calling as scores, right? And now we'll find what is the maximum probability. Let's say the car's person class has got probability of, let's say 0.5, right, or 50%. So the maximum probability will be 50%. So we'll find the index of that maximum probability. This will return us the index of the maximum probability in this course, right? In this course is a list, so we'll find the index of the maximum score, right? And that index we are going to call as class ID, because that will be the class ID, right? That will be the class ID. So, for example, the class ID for person will be, let's say, 5. So when the probability of person is max, so we'll get class ID as 5, right? So in short, we are getting the class ID of the probability, highest probability object. Then we are again retrieving the score. What is that probability? We are retrieving from scores again. We are again going to scores with this class ID, right? And we are getting that score, which is the probability, and storing that in the confidence array, right? So this confidence array. Now remember, this confidence and this confidence which I talked is different, right? They are different. So this is the confidence of the object. Confidence of detected object is indeed an object, and this confidence is storing the probabilities, right? Right? So what this probability for this first detection, if the first detection is the person, so the probability of that person we are getting here, we are storing here, right? So this confidence array is storing the probabilities. So we are then what we are doing, we are checking if the probability is good enough, right? We are considering only probabilities greater than 0.5, right? So if the probability is of that object is 0.5 or more, if the probability is greater than 0.5 and the class of that object is person, right? So we are having the class ID. So with that class ID, we are going in classes list. What is classes list? In classes list, if you remember, we have got the names of these objects, in the Coco, from coco.names, right? So we are going to class names with that class ID and retrieving that corresponding object name. So if it is person, right, if the confidence is greater than 0.5 and that class object detected is a person, if that object detected is a person, then only we are going to process that. Otherwise we are not going to process. And what processing we are doing? We are finding the center coordinates, right? Center coordinates. See how we'll get the center coordinates. So if you see, these two are center coordinates, center x and center y. So we are finding the center coordinates, center x and center y, right? Then we are going to find the width and height of the object, So detection 2 will give us width, right? And this width is the frame width, right? This width is the frame width which we got from here, no? This one, right? Frame width. So that means every so these coordinates, this and this are getting multiplied by width and height, right? For x it is multiplied by width, for y it is multiplied by width. So this will give us the center coordinates, center x and y coordinates. Center, what, whose center? The frame center, right? The frame, or not frame, but the rectangle which we are going to put around that object, right? So these will give us the bounding box center coordinates. This will give us the bounding box width and height. So this is bounding box width and height, right? So this detection 2 is giving the width. This is detection 2 giving us width. So we are multiplying this width by the width of the frame, right? And we are multiplying this height by the height of the frame, right? So that is giving us the width and height of the bounding box. So these are width, and these are the center coordinates of the bounding box, width and height of the bounding box. And now we are getting the top left corner in x and y coordinates, right? Top left corner. Why I need top left and right corner? Because once I know the top left and right corner, width and height, I can easily draw a bounding box, I can easily draw a rectangle, because I know, let's say the left corner corner is here, so here, let's say here, right? So if I know the coordinates of this, I know this height, I know this width, these four things I need to know in order to draw the rectangle, right? So that's why this is how I am computing the top left corner width and x and y coordinates. So top left corner, x and y coordinates. So now I have the bounding box information with me. What is that? The width and height of the bounding box and the top left corner, right? So with this information I can plot the bounding box. So that is what I am appending to the boxes. In the boxes list, I am putting this coordinates, bounding boxes of the first object, bounding boxes of the first object. And then in the confidences array, this is the confidences array, I am going to append the confidence score, right? Confidence score, that is the probability of that object belonging to that particular class, right? And then class ID, which we found, what is the ID of that class, we are going to append it, right? Append it in the class ID, right? Okay, so that's what we are going to do for that frame. Now after doing this, so here is yeah, that's just a minute. Yeah, so after doing this, we are now there might be redundant frames, right? There might be redundant frames. So we want to we want to get rid of those redundant frames. So we'll pass these boxes, right? So this boxes array. So this boxes array is containing the, what this array is containing? This array is containing the coordinates of the bounding boxes. So we'll pass this boxes array or bounding boxes through a test called as NMS boxes, right? So this NMS boxes will remove the redundant frames, redundance bounding boxes, right? Or redundance rectangles, right? So that's what we will be doing here. We'll be passing these boxes through this NMS boxes function that will remove the redundant bounding boxes. And then after removing the redundant bounding boxes, we'll be storing remaining bounding boxes in this indices list, and then we are going to process that indices list, right? So what we are going to do, we are going to just pick we are going to go through each of these bounding box, right? Each of this bounding box, and we are going to pick x, y, w, h from this bounding box, and we are going to put the rectangle around the frame, right? So this is the frame which we have. This is our frame. So around that frame we are going to put the bounding box, right? So this is top left corner xy coordinates. So x plus w means how from, if this is x, so I'll add w, so I'll go till this, right? If w is this much, right? That means I am drawing the horizontal line, vertical line. So this will plot the frame with this color. This is the green color of the frame, and this is the thickness of the bounding box, right? So in fact, in short, this code is actually plotting the bounding boxes on the frame, right? Around the objects in the frame, all the objects in the frame, right? Then we are appending this processed frame. To the frames array, this frames array. So this frames array will store the process frame, because later I'll be retrieving all those process frame from this frames array and put those frames in the video. So I'll repeat this for all the frames. I'll repeat this code. This while loop will run for all the frames in the video, right? And once we are done with that, we'll release the resources held by this cap, right? So cap dot release, it will release all the resources. Then we are saving this frames to the video, right? So we are preparing this video writer object. So this video writer underscore FOURCC, this is a function we are calling on CVT. This will be just set a codec by using which will be encoding the video, right? So it is MP4V. This is the codec by using, that means we are setting the codec to MP version 4. That means the video will be encoded by using MP4, right? So now here we are calling this cv2.videowriter, right? And to that we are saying that write the video to this file. This is the name of the output file by using this codec which we just created here, and this is the frame rate, right? And width and the height of the frames, in the video, right? So this line is actually writing the video in the output.mp4, right? Okay, and then we are for frame in frames, we are writing all those frames to this out, which is the name of the video. Out is the name of the video. Out is the name of the video. And now this video, so here, in fact, here the video of writer object is set. Video writer object is prepared. This object is prepared. What this object will do? This object will write the video in output.mp4 file using this codec with this frame rate 20 frames per second with this width and height of the frame, right? So that object name is out. Now we are calling the write function on that object out and writing a frame to that out object, right? So for each frame in the frames, we are taking one frame at a time and writing that frame to this out object. So this loop will run for all the frames in this frames list, right? And all the frames will be written in the video and whose name will be output.mp4, right? And then we'll release the resources held by this out, right? This is just release all those resources, right? And then we will download the video. So these lines will, this try function will download. Again, we are files.download, right? We have this files module, right? Files module here, right? Files. On that files, we are calling the download function. So download function will download the file output.mp4, which is there in Google Colab. It will be downloaded to our local machine. If the file is not there, we'll get this error. So let me run this now, right? I hope you understood the code. Let me run this. So you see the processing is started. You see you are able to see this arrow, right? Small arrow. So that means the processing of detecting the object in the video. Which video? This video cap or our drone one video this one. The processing is started, right? The processing of detecting the objects and putting the bounding boxes around those objects is started. So it will take some time. So I'll pause the video just to cut short the time of the video. So it's been around over 4 minutes, but the still processing is going on. You see, and the processing is just now finished, and we are downloading the output.mp4. So you can see here the output.mp4 file is getting downloaded. See, the video was very small. It was hardly 6-7 bytes megabits video. So for that video also it's taking 4+ minutes. I'm using Google Colab. I'm using resources of Google's. I don't know on the local machine with so you see, so this file is downloaded here. You can see here, right? So this file is downloaded here. You can see, right? So this file. So let's just play this file, which is 8.5 MB. I hope you are able to see this, right? Just now this is downloaded from here. I'll play this, right? You see. So you are able to see this, I hope. And so these persons are detected, right? Only persons are getting detected. So this person is getting this person is getting detected, right? So this person, right? So these persons are getting detected. So that's our actually our task, right? So if a person is seen, he will be detected and located, and the information will be sent to the concerned authority that so and so person is detected in this particular area. So please rescue him or her, right? So and that was the project. I hope you understood the project. The project is, we will let's say there is a person who is lost in some remote area or jungle or in some other place, and we want to perform the rescue operation for that person. So we'll be having a drone which will be flying over there doing the surveillance, and that drone will be equipped with the camera, and this drone camera will capture the video, real-time video, and we'll be sending those video to our system, our module, our software, and where we'll be processing that video, and we'll be detecting whether the person is there in this video or not, right? So if the person is seen, we'll be generating an alarm or signal indicating that a person is found, perform the rescue operation. Okay, thank you so much for watching this video. Thank you.